Next problem, the 94 Winter Olympics include the aerials competition in skiing. In this event, skiers speed down a ramp that slopes sharply upward at the end. The sharp upward slope launches them into the air, where they perform acrobatic maneuvers. In the women's competition, the end of a typical launch ramp is directed 60 degrees above the horizontal. So there we go. This here would be the 63 degree angle. With this launch angle, a skier attains a height of 13 meters above the end of the ramp. What is the skier's launch speed? So the total height here would be actually from the skis to where it was launched, 13 meters, which is 40 feet. Okay, this image here doesn't look like 40 feet. 40 feet that's quite a bit. That's like 4 stories. I didn't check if that could be actually possible, but that's what the problem says here. Okay, anyway, let's see. What is the skier's launch speed? So what we're supposed to figure out is this one here. There we go. So that's the launch speed. Remember the football earlier? There was just at impact where the launch speed was considered right at the end of the impact, and we call it a v there, the end velocity, while here to us the launch speed is the initial velocity, because now we're dealing with, well, once it's launched, what happens then? It goes up to 13 meters. So that's why there is a difference between these problems, what we consider what. So let's see. What else we know is 13 meters and it's up. So that makes it positive. Then let's see, what else we know is that gravity, of course, pulls it down, 9.80 meters per second squared. We don't know the time, but we do know some other piece of information. It's the Vy at the very top. Well, the skier just stands still. That's typical of the peak, so 0 meters per second. And the equation to use is 36b Vy equals, Vy squared equals V0y squared plus 2ay times y, with the Vy, the speed velocity at the top being 0, and then we do the algebra solving for V0y. So we get this to the other side, that introduces a negative, so we're going to have a negative 2ay times y, take the square root, equals, and we come up with something. And notice that negative here, but that ay here is negative as well, so those two negatives get rid of each other and we can take a square root, so we come up with a nice number, and then we have to decide, is it positive or negative? Well, it goes up, so we choose the positive component. Mathematically, yeah, we come up with a negative component as well, or we could, but the skier isn't going down. We know that from the problem, so we have to choose the positive one. So you come up with a positive number here, and then we're not quite done, because it says what is the skier's launch speed. It doesn't say what is the skier's vertical launch speed. It says what's the launch speed. So we're gonna do then v equals v0y times sine theta, and so here comes the angle comes into play. And now where we're supposed to figure out, let's see, oops, I did something wrong. Okay, tries again. Actually, there were a couple of things wrong. Vy equals that was correct. V0y was correct. The launch speed in the vertical equals the launch speed times sine theta. So the first time around I mixed up these two here. This is what we're supposed to figure out. So it's going to be V0, the initial speed, initial velocity, equals V0y, which we just calculated up here, divided by sine theta, equals, and there we go,